Okay, let's take a look at the Chapter 12 quiz or Chapter 12 test review. Question 1, you are given to assume that the lines that appear to be tangent are in fact tangent and asked to find the value of A. So if these two lines are both tangent to the circle, then you know it forms a right angle at each of those intersections with the radii. So 90 plus 90 plus 130 plus A equals 360. So A is equal to 50. Number 2, again, assume lines that appear to be tangent are, find the value of x. If it's tangent to the circle, that means it is perpendicular to the radius at the point of tangent C. So this is my hypotenuse. So 10 squared plus 24 squared equals x squared. So in this case, x is equal to 26. Number 3, we crossed out that 18. So again, lines that appear to be tangent are. So that means that these two lines that are tangent to the circle P have congruent segments. So 12, this is 12, that means that this is 12 and this is 12. If this is 9 and this is 9, you're asked to find AB. AB is congruent to BC. You're given the perimeter. So 2 times 12 plus 2 times 12 plus 2 times 9 plus 2 times AB is equal to 72. So 66 plus 2 times AB equals 72. So AB is equal to 3. Number 4, again, assume that lines that appear to be tangent are tangent for circle O. That means that this is my right angle. So I have x squared plus 12 squared equals x plus 8 squared. Remember, you have to FOIL the x plus 8 on the right-hand side. So you're going to have x squared plus 144 equals x squared plus 8x plus 8x plus 64, which gives you x squared plus 144 equals x squared plus 16x plus 64. Subtract the x squareds from both sides and they will be gone. They cancel. Subtract 64 from both sides and you will get that 16x is equal to 80. So x is equal to 5. Number 5, it says a belt fits snugly around two circular pulleys as shown. Find the distance between the centers of the pulleys. You're looking for this distance x. Remember, the figure is not to scale. So what we're going to do is draw that line parallel to the line connecting the two pulleys. So go to the point of tangency on the smaller circle, draw that line parallel to the line X. Remember, your right angle is where the tangent intersects the radius. This length will be 15 minus 6, or 9. So you will have 9 squared plus 12 squared equals x squared. so x is equal to 15. Number 6, you're asked to find the value of the given variables. You have several angles inscribed, or a polygon triangle inscribed in a circle, so you have 3 inscribed angles. The endpoints of this particular inscribed angle are the endpoints of the diameter, making this angle 90 degrees, which makes this value z equal to 180. Remember, the inscribed angle is half the length of the intercepted arc. This angle is 72. This is the right angle, which is 90. That means that this angle is 18. So y is equal to twice that, which is 36. This intercepted arc corresponds to this inscribed angle. So then x is equal to 180 minus 36, because this whole arc would be 180. We'll subtract the 36 and get that is equal to 144 degrees. Number 7, you're asked to find the values of the given variables. Feel free to take highlighters if you wish to draw those inscribed angles. If you're looking for angle A, the inscribed angle A corresponds to the sum of these two arcs, 120 and 95. So this is 215 degrees. A is half that, so A is equal to 107.5. B is now this inscribed angle. That intercepted arc will be 80 and 120. So that whole arc is 200, which means B is equal to 100 degrees. C is this inscribed angle. The intercepted arc is 145 degrees. That means that C, the inscribed angle, is half that at 72.5. And then finally, D is this inscribed angle corresponding to this intercepted arc, which is 160, which means D would be equal to 80 degrees. Also remember that the opposite angles of a quadrilateral inscribed in a circle should add up to 180. So opposite angles here will be B and D. They add up to 180, and A and C, and they also add up to 180 degrees. Number 8, find the value of the given variable. You have an inscribed angle, and the intercepted arc is 94 degrees. So y is equal to half the length of the intercepted arc, or 47. Note that x, the inscribed angle x, shares the same intercepted arc, so therefore x and y are the same, and they're both equal to 47. Number 9, find the value of the variable. You have two secants that intersect inside the circle. So you're going to take one arc measure plus the other arc measure, so 115 plus 78 divided by 2 is equal to, nope, erase that, I'm sorry. The arc measure is x. So I have 115 plus x over 2 equals 78. So that is 115 plus x is equal to 156. So x is equal to 41 degrees. Okay, so the large arc plus the small arc divided by 2 equals the angle measure. Number 10, again I have the large arc plus, or two arcs, I'm going to add them together because the secants intersect in the circle, so 56 plus 78 over 2 is equal to x. That gives me 67 degrees is x. X and y are supplementary. X is 67. So therefore, y is equal to 113 degrees. Number 11, I have two secants that intersect outside the circle. So now I will subtract the smaller arc from the larger arc. So this is 106 minus 40 over 2 equals the measure of that angle, which is x. So that gives me 66 over 2 equals x, so x is equal to 33 degrees. Finally, number 12, actually that's not the last one, but number 12 is a tangent and a secant, and I'm looking for the segment lengths, not the angle measures. So I have the tangent squared is equal to the length of the secant, 12 plus 6, times the piece that falls out of the circle. So that gives me x squared is equal to 18 times 6, which is 108. So x is equal to 6 root 3, or approximately 10.4. Next one is number 13. It says determine the center and radius of the circle. The center of the circle, remember the general form is x minus h squared plus y minus k squared equals r squared, where h and k are the center. So here it's x plus 6. General form is x minus h, so this becomes negative 6 and 2 as the center with a radius of 8. Number 14, write the standard form of the equation for a circle with a center at 5, 7 and a radius of 12. Again, go back to your standard form. You'll have x minus 5 squared plus y minus 7 squared equals r squared, which is 144. Number 15, write the standard form of the equation of a circle with endpoints of the diameter at -2, -2, and 8, 6. First thing you need to do is find the midpoint of the diameter. That is the center of the circle. So -2 plus 8 over 2 and -2 plus 6 over 2 gives me a center of 3, 2. Once you have the center, you need the radius. So the radius is equal to the square root. You're going to use the center, and either of these points, doesn't matter which one. So 3 plus 2 squared plus 2 plus 2 squared. the square root of 25 plus 16, which is the square root of 41. Now you have the radius, you have the center, so x minus 3 squared plus y minus 2 squared equals 41. That's the equation of this circle with a diameter of -2, -2, and 8, 6. Finally, number 16, describe or draw the locus of points 1 centimeter from AB and 2 centimeters from A, where AB is 1.5 centimeters. So you have AB, let's say that is 1 centimeter. Let's move that a little bit. So there's AB. AB is 1.5 centimeters. And you want to describe the locus 1.1 centimeter from AB. So that will be this oval. It's about 1.5 centimeters from AB. And then 2 centimeters from A. Okay, so the points that satisfy both of those conditions are these 4 places that the circle and the oval intersect. And that's mostly what the test will look like. If you have any questions, you can ask me before class. Have a nice evening.